the human eye. Sight is arguably one of our most vital senses, but that doesn't mean it's foolproof. Our eyes can be easily deceived by simple anomalies in perception. An illusion is created when your eye and your brain don't agree on what they're seeing. The results can be fascinating, even more so under the weak influence of gravity, microgravity. The image reversal in space experiment measured how astronauts responded to a series of optical illusions and compared their reaction times for recognizing the different images to data recorded while the crew was on Earth. The astronauts indicated which perception of an image they saw by striking one of two keyboard keys in the IRIS software. Dr. Robert Thirsk, a Canadian astronaut, developed this experiment with students from the International Space University, which sounds kind of fake. Good. The experiment is intended to measure the amount of time it takes for someone to perceive an illusion in space.
IRIS is housed on this laptop computer and is executed using the interactive IRIS software and two keystrokes on the laptop keyboard.
In microgravity, it can be difficult to determine one's orientation. Any wall could be the floor, any floor could be the ceiling.
I tended to, in space, have less preference for looking at the two ambiguous figures. Both were reasonable to me, and the flip-flops between my perception of one view versus another seem to be less frequent in space than on Earth. We need to know the depth of an object, and we also need to know its orientation as well. Perception on doing surgery will be important. Results from IRIS will help us design adequate procedures, adequate checklists, smarter human-factored hardware and software based on the results of the IRIS experiment.